In this video, we will solve shear problems. Well, the first one is a section and dimensions are given. A shear force 30 kilonewton is applied. Question is find the maximum shear stress. Well, this is my shear stress formula. I know that the maximum shear stress is on the neutral axis, and I have determined these Q, V, I, and T values. Okay, let's start with the moment of inertia. Here, for the calculation, first the big rectangle, the full rectangle with the dimensions 200 and 310 is selected, and the moment of inertia for this rectangle is calculated. Then the blue areas are taken as a minus area, and the moment of inertias for these two areas are, this dimension is 25, so the remaining dimension over here is 175. Well, this height is 250, so it is minus 1 over 12, 175, 250 cube, and that is my result, moment of inertia for this section. Next, I need to calculate the Q value for my maximum shear stress point, which is the neutral axis. So let's take the upper part, put it here, and calculate the Q value as y prime times A for the two rectangles. First, this rectangle, well, we have to calculate the area, and the distance of this of the centroid of this area from the selected axis is 0.025. Next, we come to this second area. Well, this is the area, and the distance of its centroid from the axis is 140. So if you do this calculation, you find that the Q value for this axis is that value. Next, well, T, which is the width, is obvious. It's 25. So let's put the values Q, V, Q, I, and T values, and the result is 4.62 is the maximum shear stress which occurs in the middle on the neutral axis. Next question. Determine the maximum shear stress in the beam at the critical section where the internal shear force is maximum. Well, the beam is given. There is a distributed load, and the section is given. And the question is, the first question is, where is the maximum shear force? At which location? So we have to draw the shear force diagram. For this, the first I have to do is, instead of this distributed area, I put 10 times 3, 30 kilonewtons, and then for the triangle, I put a force 15 kilonewton. And the next step is write an equilibrium equation. I take the moment in sigma ma equals to 0, and with this I find by, and if you take the moment around this point B, then you find ay. We will not go into detail, but we know the support forces, so we can draw the shear force diagram. Here I have 27.5 trying to rotate clockwise, it is positive 27.5. Here I have in the opposite direction minus 17.5. These are the 2 points of the V on the V curve. We know that the V over dx is minus the distributed force. And as you see, the distributed force where in the first part, I mean this part, is 10. So when I start from this point, my slope is minus 10. I go down, how long? 3 meters. 3 meters is the middle, so I go down. My slope is dv over dx minus 10. When I go 3 meters, well, I reach this value. It is minus 2.5. Okay. When you go with the slope 10, 3 meters, you go down minus 30, and the value is given over here. What about the second section? In this section, at the beginning, the slope is again 10, and at the end, the slope, which is the distributed force, is 0. So my V shear force diagram will look like this. Well, this is written in clear form. As you see, your maximum shear force is 27.5. Okay, let's calculate the shear stress. Well, the shear stress occurs on the neutral axis. Okay, it will be somewhere here, but we have to determine the location of this neutral axis. First, start with that. Take this axis and try to determine y bar. Okay, y bar is given with this formula, and here the position of the centroid is determined by this dimension, and here I have 1, 2 areas. If you do the calculation, you can find that y bar is 0.12. We will not go into detail of the centroid calculation. Next step is to calculate the I value. Here again, I have to calculate the I value according to the neutral axis. So each area has its own I value, and this value has to be shifted to the neutral axis, as we know from our previous videos, and at the end we have the moment of inertia for the section according to the neutral axis. Now I have to calculate the Q max value, which is for the neutral axis. For this purpose, I cut, and I can take the upper part, but since it's much easier, I take the lower part. So the centroid of this area is 0.06 away from the neutral axis, and this dark area is calculated as 120 times 30 here in meters. So the result you have here as 0.216 10 to the minus 3 meter cube. Okay. Now take the stress formula. Q max 27.5 kilonewton. This is in newtons. Q max we have calculated as meter cube, and this value is the moment of inertia, and that is the width. The result will be in Newton per square meter, which is pascals, and you can convert to megapascal. and the maximum shear stress on the neutral axis will be 7.33 megapascals. Okay, the last question. Here we have two pipes. The upper pipe, which I show in red, and the lower pipe in blue. These two pipes are connected with the help of a pin. The diameter of the pin is given, the force is given. Question is, find the safety factor. The second part of the question, well, this time the connection will be made without the pin. So they will remove the pin and glue these two pipes along the surface on which they are connected, and if this glue has an allowable shear stress, that means if the shear stress on this area will be higher than 15 megapascal, the glue will fail. So we have to take a distance LK and find the necessary distance so that there will be no fail. Well, for the pin, the shear strength and the tensile strength is given. That's the tau value, and that is the sigma value. Okay, let's start with the maximum shear stress in the pin. Here we have our shear force, and these two sections are under shear stresses. And how do you calculate? Let's try to find the average shear stress, which is the force, is divided by 2 times the area. But we all know that if you have a section and a shear force, the distribution is not uniform. So we shouldn't use the average value, and the maximum shear is on the surface, and for a circular section, this is 4/3 times the average value. So you see this relation over here. The average is F/2A, and this is the area of the cross-sectional area of the pin. And if you organize this relation, you find this formula. This maximum shear stress should be less or equal to the shear strength of the pin material divided by the factor of safety. Well, here the factor of safety is asked. So if you organize this relation according to factor of safety and put the values, numerical values, you will find that the factor of safety is 2.28. Second part of the question, here we try to make this connection by gluing. Okay, this is the area where I apply the glue. Okay, so the diameter is, here I have 70 minus 5 minus 5, the diameter is 60, and this length is LK, which has to be determined. So the glued surface is dk times pi times LK, and the force divided by this area, which is the average force, force divided by the area should be less or equal to the allowed shear strength of the glue. This time, well, the critical point is the glue, and this was given us as tau allowed, which is 15 megapascals or Newton per square millimeter, and the force we know the diameter we know, and we find that the necessary length is 53.1, and then we will be below the allowed shear stress in the glue. Okay, this was our last problem. In this video, we solved 3 shear problems, and thank you for listening.